In this part of demo, we look at zero downtime updates to an existing inference service deployed on HPE Private Cloud AI. So let's use a Python client for this example. So you can see that the Python client is using the uh, LLM inference endpoint deployed on private cloud AI. And let's just also check that the inference service is working as expected. So you can see that it is running the Llama 3.18b instruct model, and I can also get the chat completions responses. So I can get the inference done based on the prompts that I'm sending to the model. So now what I'm going to do is I'm going to run a client continuously. So I have a set of prompts. I'm going to sample those prompts, and I'm going to send those prompts in a loop, in a continuous loop, to the inference endpoint. So this will simulate a client using the inference endpoint on an ongoing basis. So let's just start it. And as you can see that it's a loop that will continue. So you can see that for each inference there is a prompt that gets sampled, and then the inference is done with that using this particular LLM API endpoint that's deployed on private cloud AI. Of course, I have deployed the version 16. Don't want to change it, but I'm going to simulate a change in the API endpoint. I can change many different elements, but in this case, I will simulate a change in the scaling profile. So for example, my current profile is that any concurrency 50 or above, I want to scale the number of instances deployed to 2. So let me just simulate some change to the scaling profile. So maybe instead of scaling to 2, I want to scale to 4, right? So let's just simulate that change. So these kind of changes can happen. You may want to change the scaling, you may want to change model version, or you may want to change other elements, right? It's a very realistic scenario. So as you can see that as soon as I submit a change to the deployment, to the model deployment, I get a new deployment that starts building up. So you can see that the new deployment is coming up. But the important point here is that the existing deployment is still running, and the inbuilt software load balancer is using the inbuilt deployment until it can smoothly switch over to the new deployment. So you can see that my client is still acting, functioning as expected. So you can see that it's generating inference. So there is absolutely no downtime to my client. My client is still working as expected. It's sending prompts, it's getting responses from the LLM endpoint, and it continues. There's zero downtime. So you can see that it's still running quite well without any issues, and the model deployment is ongoing. So we just need to keep it running until the model deployment is finished. So we might catch up towards the end where the model deployment will be done. But as you can see, the client is working seamlessly. There's absolutely no downtime, there's no disturbance, no error, nothing on the client side. For client, the API endpoint is working as expected. No change to the API endpoint, even though the deployment got changed. So you can see that now the deployment got changed with the new scaling characteristics that I configured, and it's successful. It's updated with the new characteristics, new settings, and you can see that there was zero downtime. You can see that all the inference requests that were sent to the API endpoint for a very long period of time, all are successful, and in fact even ongoing requests are successful. So you can see that the inference is taking place, and it was always taking place during the time the inference API endpoint was being updated. So this is the power of private cloud AI. It can deliver a zero downtime updates to the inference API endpoint. So the clients do not need to be affected when inference endpoints are updated. And the inference continues. We just want to validate that there are no errors. And the model is deployed with the new characteristics. So everything is successful as expected. Thank you.